The process of discovering new elements. New elements are usually discovered through experiments in particle accelerators or nuclear reactors. Scientists bombard atomic nuclei of known elements with high-energy particles to create new, heavier elements. These experiments require precise conditions and advanced technology, as many new elements are highly unstable and exist only for fractions of a second before decaying. Synthesizing super-heavy elements. Most new elements belong to the category of super-heavy elements, which have atomic numbers over 100. These elements are created by colliding two lighter nuclei to form a heavier nucleus. Because of their instability, super-heavy elements often decay almost immediately, making it challenging for scientists to confirm their existence and study their properties. Confirmation of a new element. To confirm a new element's discovery, scientists must reproduce the experiment multiple times and observe consistent decay patterns. Verification is overseen by the International Union of Pure and Applied Chemistry, IUPAC, which ensures that the findings are credible. This rigorous process is essential to authenticate the element and recognize it as part of the periodic table. The role of IUPAC in element discovery. IUPAC is responsible for overseeing the discovery and naming of new elements. Once researchers provide sufficient evidence, IUPAC reviews the findings to verify the discovery. If the element is confirmed, IUPAC then collaborates with the scientists to determine an appropriate name, following established naming guidelines. Naming guidelines for new elements. Naming new elements follows specific conventions. According to IUPAC guidelines, elements can be named after a mythological concept, a mineral, a place, a property, or a scientist. The name often reflects the element's origin or honors contributions in science, and must end with IUM, inner, or on, depending on the element's group. Honoring scientists and places. It's common for newly discovered elements to be named in honor of notable scientists or places significant to scientific research. For example, curium honors Marie and Pierre Curie, while californium is named after the University of California, where it was discovered. This tradition celebrates scientific achievements and acknowledges institutions' roles in advancing chemistry. Element symbols and atomic numbers. Each new element is assigned a unique atomic number, which represents the number of protons in its nucleus. Additionally, the element receives a 1 or 2 letter symbol, usually derived from its Latin name or the name given by the discoverers. These symbols are designed to be simple and recognizable, fitting into the periodic table's established format. Challenges in discovering new elements. Creating new elements is highly challenging due to their instability. Super-heavy elements decay rapidly, limiting the time scientists have to study them. Advanced technology, precise conditions, and significant funding are required to synthesize and confirm these elements, making their discovery an impressive scientific feat. The future of element discovery. With advancements in technology, scientists continue to explore the potential of synthesizing even heavier elements. Researchers hope that these elements may possess unique properties or greater stability, opening new possibilities in science. However, as atomic numbers increase, creating and studying these elements becomes even more complex. Contribution to scientific knowledge. Discovering and naming new elements enriches our understanding of atomic structure, nuclear physics, and the limitations of matter. Each new addition to the periodic table represents a step forward in our knowledge of the universe, providing valuable insights into the fundamental building blocks of matter and the nature of chemical elements.